Hello, my dear students and the rest of the learners. Welcome to part 10 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this tutorial, we are going to be looking at our next selection control structure or our third selection control structure by the title or by the name nested if control structure. My name is Meme JM, or you can simply call me Emily Swap. What is a nested if control structure or selection control structure? Nested if selection control structure is a control structure that is used in a situation where there are several options to be taken. That is more than one or more than two actions to be taken, but with only one action being selected depending on the condition that has been met. It is composed of if structure inside another if structure, either under the true part or under the else part of the letter A structure. During execution, the first condition is evaluated, and if it returns true, then the first instruction under it is evaluated and the rest of the conditions are not tested. Otherwise, if it evaluates to false, the second condition is tested. If it evaluates to true, then the second instruction is evaluated and the process continues. So the following is the syntax for this structure. In other words, my dear students and the rest of the learners, the nested if selection control structure gives the user more opportunities for an action to be taken. In other words, if you are dealing with a situation where there are several actions to be taken, but only one of those several actions should be worked on. In other words, if you're working in a situation where there are several conditions to be met, with each condition leading to a certain action, but only a single action is supposed to be taken, then we use what we call the nested if selection control structure. In other words, the nested if selection control structure is an advancement of the if-else control structure that we learned in part 9 of the series, which is accessible from Emily Swap ICT YouTube channel. And therefore, in the if-else control structure, there are only two actions available, where when the condition is true, one action is taken. Otherwise, if the condition is false, the second action was taken. Now, nested if gives you more opportunities or more chances for more options, more than one or more than two actions. But regardless of that, it's only one action is taken and the rest are ignored. So if you are dealing with a situation where there are several actions or there are several conditions to be tested, one action to be taken, then nested if is the best candidate for you. So its structure is as follows. If the first condition is true, then take a certain action. Else, if second condition is true, then perform action 2. Else, if that condition is true, take that action. And that will continue. So several conditions are available. If the first condition is not true, then the second condition is tested. If the results of the second condition is not true, then the third condition is tested. If the results of the third condition are not true, then the fourth condition is tested. So there are several conditions that are tested when the prior or previous condition is not true. So when a condition is not true, the next condition is tested. If it also evaluates to false, the next condition is tested. And those conditions are tested until the right condition is found. So if the first condition is not met, the second condition is checked. If the first and second conditions are not met, then the third condition is checked, and so on. Once a certain condition is met, its instructions are then executed or action is taken. The following is therefore a sample pseudocode, a sample flowchart and a sample pseudocode or a sample source code for a program that accepts radius. Then if the radius is less than 5, it calculates the perimeter and displays it on the screen. Otherwise, if the radius is between 5 to 10 centimeters, or if the value entered is between 5 and 10, the processor computes the area and displays it. Otherwise, if the value of radius or the value entered is more than 10 but less than 15, it calculates both the area and the perimeter and displays them on the screen. Otherwise, the program displays the message, the circle is too big and the calculation can't be done. So you can see there are several, or there's an action that will be done if the value entered is less than 5. Another action will be done if the value entered is between 5 and 10. Then another action is taken if the value entered is between 10 and 15, and another action is taken if the value entered exceeds 15. So for the pseudocode, we have the heading or the title, calculate area and or perimeter based on radius entered. Then we have start. We set it by 3.143 or 3.142. Then prompt the user for radius. We read the radius. Then we begin checking the conditions. If the value of radius is less than 5, we compute the perimeter using the formula 2 times pi times radius and display it on the screen. Otherwise, if that condition is not met, we check the next condition, which is if the value of radius is more than or equals to 5 and less than or equals to 10, that means between 5 and 10, compute the area using the formula pi times radius and display it on the screen. Otherwise, if the first condition is not true and the second condition is not met, check the third condition, whereby if the value of radius, the value entered is more than 10 but less than 15, the program or the processor will compute the area using the formula pi times radius and also compute perimeter using the formula 2 times pi times radius and display it on the screen. Otherwise, if neither of those conditions is met, take the last action. Display the message that the circle is too big and the calculation can be done and stop the program. So that is our pseudocode. The same can be represented using a flowchart. Always remember that the flowchart has a title. The title in our case is flowchart for a program to calculate area and or perimeter based on radius entered. And that's our flowchart. You can see we have the start there. We have the assignment of 3.143 in the memory location called pi. And then we prompt the user for radius and we begin checking our conditions. The first condition that they checked is if the value entered in radius is less than 5. If the value entered is, for example, 1, 2, 3, 4, then that is true. The program or the processor is going to compute the perimeter of a circle and display it on the screen and exit or end the program. Otherwise, if the value that is entered is not less than 5, then the second condition is checked. And the second condition is the value of radius greater than or equals to 5, but less than or equals to 10. So if the value entered is ranging between 5 and 10, that means the condition is true. This part will be followed. The processor will compute the area and display it on the screen, and the program will end. However, if the value entered is neither less or neither or is not between 5 and 10, then we go to that condition. We check: is the value of radius or is the value which has been entered more than 10? but less than 15, or and less than 15, that means between 10 and 15. If that is true, if the value entered is, for example, 11, then the processor will compute the area and perimeter of the circle and display them on the screen and end the program. Otherwise, if none of those conditions are true, the value entered is not less than 5, it is not between 5 and 10, it is not more than 10, but less than 15, then meaning the value is more than 15, then it simply means that none of those operations can be carried out, and therefore the message to be displayed on the screen is this circle is too big and the calculation can be done and the program will terminate. So my dear students and the rest of the learners, you can see that only one path will be followed at any time. Only one path will be followed at any time. If the value entered is less than 5, then this is the path that will be followed. If the value entered is between 5 and 10, this is the path that will be entered or that will be followed. Otherwise, if the value entered is more than 10 but less than 15, this is the path that will be followed. Otherwise, if the value entered is not within that range that we have looked at, meaning none of these conditions is true, none of these conditions has been met, then the path that will be followed is this one. This message will be displayed on the screen and the program will terminate. So my dear students and the rest of the learners, let us now look at a program implementing nested if control structure. So our program is, the comment is, calculate area and the perimeter based on radius entered. Then we have our comment again, compute both area and perimeter, or both. Our preprocessor directive is there. Then we have our main function there and our body, where we are declaring a constant memory location for holding the value of pi. And then we compute, or we set memory location assigned for holding value for radius, area, and perimeter. Then we prompt the user to enter the radius for a circle, read that value, and assign it a memory location called radius. And then we begin checking our conditions to know which action will be taken. So the first action is, if the value of radius, if the value memory location called radius is less than 5, then do the following. Compute the perimeter of a circle using this statement, display that perimeter on the screen, and come out of the selection control structure. Otherwise, if that section is not true, do the following, or take the following action. Check if the condition, the second condition is true. So check if the value of memory location called radius, the value entered there is greater than or equals to 5, and it is less than or equals to 10. So if that is true, do the following. Compute the area using this expression and display the value of area as per this statement and come out of the selection control structure. Otherwise, if the value entered is still not within, or the value entered does not fall within that category, check the value condition. If the value memory location called radius is more than 10 and it is less than 15, if that is true, the program or the process is done, compute the area using this formula or this expression, then also proceed and compute the perimeter using this expression and display these statements on the screen. The area for this circle is that, and the area of perimeter is that. And the perimeter is that. So this program here, or this statement has a small error. So let's rectify this error. So it's supposed to read area for this circle is area. Now, when you look at this other statement here, this statement is a repetition. You can see this statement and this one is a repetition. So we can erase one of these statements from there. Remember, this is our program. So we can have it as follows. We avoid duplication. So we have said that our boundary condition is if the value in the memory location is more than 10, but less than 15, compute both area and the perimeter. Compute both area and the perimeter. Now note here, as I repeat, I want to check this section here. We have begun by computing the perimeter here. Then this next section, when the control structure evaluates true, on the condition evaluates to true, we compute the area. Now, on the boundary condition, if the value is between 10 and 15, we compute the area, we compute the perimeter, then we display the following message. Area for this circle is that, and the perimeter is that. Then from there, we come out of that control, or that section. Otherwise, the last part is for default. If none of those conditions are true, meaning the value is not within those ranges of the conditions we have checked, we just request the processor to display the message that this circle is too big and the calculation can be done. This is good programming practice, so that the user is able to know why his or her program is not performing any action. And we take the control back to the operating system and end the program. Let us now write this program in Falcon IDE so that we see how it will behave. We run it, we code it, we run it. That is, we code it, we compile it, we execute it, so that we see how it will behave. So as usual, we have to begin. We have to launch Falcon IDE by clicking on Start button, and then you type Falcon. So once our IDE, or once our IDE program has launched, you click on the file, point on new, click on the project, and the new project, we click on empty project, and click on next. And the project name, we give our project a name. So our project name will be nested if. We choose C compiler and click on finish. From there, we create our program and our project. Then we rename it. So the name of our program will be nested if. Then you click anywhere. So from there, and our IDE, that's our data section for our program or our file, you can decode our nested if program here that we have already discussed. So we can code or write our program here. So you can always, remember, you can always type your set of instructions directly for the program as we have discussed. But if you have typed it, for example, in a Word processor, like Microsoft Word, you can always copy it and paste it in your IDE, just as I have done. So this is our program. Ensure it is well nested or it is well indented. So always note that your program should always be as readable as possible. So you can always indent your program in a way that you can be able to tell which part is doing what. So I'm just trying to organize my instructions in a nice way by indenting them as necessary. Remember that even spaces between one instruction and the other are supposed to be meant to make your program as readable as possible. So that's our program. So we have coded our program here. You can see a nested if has several statements under each of the sections. So this is the first condition. Under it, we have the else, and then we have another if. We also have this else here and another if. And then we have the last if or the last else section, which we usually call the default statement in the case none of the conditions are met. Now, once you are done with coding your program, you save it by clicking on File, then Save. And remember, when you are saving it for the first time, you are also saving the project. You select the location where you want your program to be saved or your project, give it a name, and it's always good to ensure this name is the same name you have been using for the project instead of changing, and then you click on Save. Now, you can compile the program by clicking on Run, then compile. If there are any errors, you debug. If there isn't any, you'll be told that the compilation is successful under the IDE status bar, as you can see at the bottom of my screen. Once your compilation is successful, meaning that the program has already been converted to object code, you can click on Run and then Run command. Now, the run simply tells the processor or the processor to pick the object code and perform the tasks therein. So this is our output screen. So our program is executing. So we are prompted to enter radius for a circle. Let's see. If we enter a value which is less than 5, what we expect to see is the perimeter only should be executed. So let me enter, for example, 3 and press enter. You can see after entering value 3, it's only perimeter which has been computed because that is the first condition here, as you can see. So that's the first condition. And the program terminates. So let's go back there. Let's type, for example, let's run our program or run it. And then this time around, enter a value like 12. So when we enter a value like 12, let's see what will be computed. You can see the program has been able to compute both area and perimeter. That means which section of this program has been executed. It is here, where the value of radius is more than 10, but less than 15. So that's why the program has been able to compute, or the process has been able to compute both the perimeter and the area. What about if, for example, we run it again and we enter a value which is more than 15? For example, let's enter 23. Now, if we key in 23, we expect which part to be executed. So let's press enter and see. You can see the value or the statement that has been displayed on the screen is that this circle is too big and the calculation can't be done. So which part is that of this program? Now, the part of this program that has been executed is this part, the last else part. And with that, my dear students and the rest of the learners, you can always save your program, close all. Let us also exit from our IDE And that marks the end of part 10 of the series. So that's how we use or we work with the nested if. You can now proceed, watch, listen, and practice part 11 of the series, in which you are going to learn about what we call the switch selection control structure. Congratulations for learning part 10 of 29 on nested if selection control structures in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on MLSWAP ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. Remember, you can also join MLSWAP ICT YouTube channel with additional rights by joining as a special member through clicking of the button join, and then you choose the type of member you would like to be. For any further correspondence, kindly write to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 11 of the series, and God bless.